You know, when you talk to someone outside of IT about what a modern enterprise data landscape looks like, there's usually this expectation of order.
Oh, yeah, like a perfectly organized system.
Right. They picture this giant, pristine filing cabinet. The CEO says, I need our customer records. And you just pull open this heavy metal drawer labeled customers.
And the file's just sitting right there.
Exactly. In a crisp manila folder, just waiting for you.
Which is a beautiful fantasy, honestly. It really is.
It is. But, I mean, that centralized, predictable world might have existed 30 years ago.
Right, when everything just sat on one big mainframe in a chilly basement somewhere.
Yeah. But then you step into the actual reality of a modern organization today, and suddenly that filing cabinet isn't just disorganized. It is actively on fire.
Oh, completely on fire.
And the papers aren't just scattered on the office floor. They're scattered across, like, 3 different competing cloud providers.
And dozens of those aging on-premises servers that nobody wants to touch.
Yes, the ones gathering dust. And an endless, sprawling web of SaaS applications.
It's an absolute fragmentation crisis. I mean, you have marketing data sitting in an Amazon AWS bucket over here.
Right.
And then you have financial reporting happening in an Azure SQL database over there.
And sales teams are probably spinning up their own shadow IT tools, right?
Oh, guaranteed. And the poor IT professional is just standing in the middle of this chaos trying to figure out what data the company actually owns.
Let alone how to protect it.
Exactly.
And, that feeling, that overwhelming fragmentation is exactly what we're tackling today. So if you're an IT professional trying to make sense of this sprawling multi-cloud reality, you are in the right place.
You really are.
We're going to take a journey today from the absolute foundational concepts of how you even begin to map this chaos all the way down into the deep mechanical engine room.
The fun stuff.
Yeah, the fun stuff. How a unified system actually scales up to handle petabytes of data without completely breaking the bank.
Yeah.
And looking at the backdrop you've set up behind you today, I'd say you're ready to map some chaos.
I thought it was fitting. It's this massive illuminated cityscape at night. Millions of lights, distinct neighborhoods, highways connecting them all.
It looks awesome.
Thanks. Some areas are brightly lit and obvious, and others are, well, a bit in the shadows, just like a modern data estate.
It's the perfect visual, really. It's a living, breathing, sprawling entity.
Right.
And to tame it, we are pulling from a stack of incredible sources today.
We've got some great material.
We do,
Huh.
including the architecture and strategic implementation of Microsoft Purview, along with Microsoft's official Learn documentation on Purview data governance and the data map.
Very comprehensive stuff.
Yeah. But I want to make a promise to you, the listener, right now. If you don't have prior Azure architecture experience, do not worry. Okay, let's unpack this. We are going to break down complex Azure concepts into plain English.
That's the goal. Because the concepts here, they're universally applicable, whether you're a 20-year Azure veteran or you've never provisioned a cloud resource in your life.
Exactly. So let's start right at the root of the pain. You called it a fragmentation crisis earlier.
Yes.
The source material uses a very specific term for how organizations traditionally tried to handle this mess. They call it siloed oversight.
Siloed oversight, yeah.
So what did that actually look like in practice for a company?
Well, historically, the way an enterprise bought software was completely reactionary. So picture this. The chief information security officer realizes they have a vulnerability. They need to protect sensitive data.
Okay.
So they go out and buy a massive, expensive security tool. It basically builds a wall.
All right, so that's silo number one, the security silo.
Right. Then, maybe a few months later, the legal department realizes new privacy regulations are coming down from, say, the EU or California.
Oh, and they panic.
Total panic. So they go out and buy a completely separate regulatory compliance tool. And that tool's only job is to scan for policy violations.
Silo number two, compliance.
Exactly. And then the chief data officer complains that their data scientists can't actually find any of the clean data they need to train their models.
So let me guess. They buy another tool.
You guessed it. They buy yet another separate tool, a data cataloging software, just to do data discovery.
So you have 3 different executive teams buying 3 different tools from 3 completely different vendors. I'm guessing these tools do not play nicely together?
Oh, they don't play together at all. I mean, they have entirely different architecture. So if you are the IT admin, you have 3 different windows you have to look through just to understand one single database.
Wow.
Yeah. The catalog tool tells you the database exists. The compliance tool tells you it fails an audit. and the security tool tells you who's trying to hack it.
But because they don't talk to each other, you basically have to manually stitch that narrative together in your own head.
Exactly. It is incredibly inefficient.
And really dangerous, right? Because if the security tool doesn't know that the catalog tool just discovered a brand new table full of, like, unencrypted social security numbers.
Yeah, that is a massive blind spot.
Yeah.
And you've hit on the exact reason this siloed model completely failed. You cannot secure what you cannot see.
Right.
And conversely, you can't innovate with your data if your security team has locked it down so tightly because they just don't trust the compliance posture.
It's a catch-22. So Microsoft looks at this disjointed nightmare and decides to build a unified engine.
Yes. They recognize that data discovery, data compliance, and data security, they're not three different problems.
It's okay.
They are three facets of the exact same problem, which is data governance. So what we know today as Microsoft Purview represents a massive synthesis.
They mash things together.
Basically, yeah. They took two distinct legacy products, the old cataloging tool, which was called Azure Purview.
Confusing name overlap there, but okay.
Yeah, right, the old Azure Purview. Yeah. And the massive suite of Microsoft 365 compliance solutions. And they functionally welded them together into a singular, cohesive platform.
Which means, practically speaking, for the person managing this, you finally get one pane of glass.
Exactly. It's a transition to an integrated intelligence model. You log into one portal and you see the catalog, the lineage, the compliance alerts, and the security policies all overlaid on the exact same map.
Okay, I love the idea of one pane of glass. Who wouldn't? But that brings up an immediate operational question for me.
Lay it on me.
If you have one centralized portal, doesn't that imply you have one centralized team trying to control everything? Because in my experience, the moment central IT tries to lock down all the data in an entire global enterprise, everything just grinds to a halt.
It does.
You know, you need a simple sales report, you submit a ticket to IT, and you wait 3 weeks for a guy who doesn't even know what a sales qualified lead is to approve your access.
Yes, the infamous IT bottleneck. Total central control is a very outdated model. It completely stifles business agility. But the opposite extreme is just as bad.
You mean the Wild West?
Right. Decentralized chaos. Every department buys their own tools, sets their own rules, and nobody knows what's actually compliant and what isn't.
So what's the solution?
Well, what's fascinating here is that the Purview architecture relies on a federated approach to data governance.
A federated approach. Okay, define that for me.
Yeah.
How is that different from the dictator IT model or the Wild West model?
Federation is the intelligent middle ground. In a federated model, the central data office, like the high-level governance board, they don't micromanage the data.
Okay.
Instead, they define the overarching rules, the guardrails, the compliance baselines. They might say, rule number 1, any personal identifiable information, PII, must be encrypted at rest and restricted to vice president level and above.
Got it. So central IT writes the law.
Exactly. They write the law. But central IT does not go through millions of databases trying to figure out which specific columns actually contain that PII.
Because, like I said, the IT admin doesn't understand the nuances of a marketing campaign database.
Oh, right. To an IT guy, a column named Campaign Target Alpha is just text. It means nothing.
But to a marketing director, that column might contain the personal email addresses of their highest net worth clients.
Precisely. So federation pushes the actual execution of governance down to the domain experts, the individuals who actually work in those departments and use that data every single day.
Oh, okay.
They become the designated data owners and data stewards.
Wait, so the marketing director or like a senior marketing analyst is actually logging into the Purview portal?
Yes. The central engine gives them the interface. The marketing data owner registers their specific marketing data sets. They apply the business glossary terms.
This makes so much sense.
They are the ones who flag Campaign Target Alpha as highly sensitive PII. And most importantly, when a junior analyst requests access to that data, the request doesn't go to some random IT ticketing queue.
It goes directly to the marketing data owner.
Yes.
That is brilliant, because the marketing owner can look at the request and say, oh yeah, Sarah needs this for the Q3 report. Approved. It takes 5 minutes instead of 3 weeks.
Exactly, and Sarah gets her data. But because the central guardrails are enforced by Purview in the background, Sarah can't accidentally email that data set outside the company.
Wow.
You get the agility of decentralization with the absolute safety of centralized policy enforcement.
Okay, I am entirely sold on the federated workflow. It really empowers the right people. But I have a massive problem with the underlying mechanics of this unified engine concept.
Oh, I had a feeling you might. Where's the friction?
The friction is security.
Okay.
If we're talking about a massive Fortune 500 enterprise, they have petabytes of data, highly classified intellectual property, unreleased financial earnings, patient healthcare records.
Very sensitive stuff, yeah.
And you are telling me we are bringing all of this visibility into one unified Microsoft Purview platform in the cloud.
Yes, we are.
So are we literally copying all of an organization's most sensitive data from all over the world and just dumping it into one giant centralized Purview database so we can govern it?
I see where you're going with this.
Because if I'm a bad actor, if I am a hacker or a ransomware syndicate, that sounds like the ultimate jackpot. I don't have to breach 50 different systems anymore. I just have to breach Purview, and I get the entire company's data in one convenient download.
That is, without a doubt, the most important question an architect can ask, and it's the exact reason why Microsoft did not build the system that way.
Oh, thank goodness.
Your fear is completely justified, which is why the answer to your question is a resounding definitive no. We are not copying the data.
We aren't moving the data at all,
Yeah.
0 copies.
Not a single byte of actual record data. And this brings us to the core foundational philosophy of the entire platform. If you remember one thing from this deep dive, it is this principle: metadata, not data.
Metadata, not data.
Okay.
I want to spend some real time unpacking this because this feels like the hinge upon which the whole architecture swings.
It truly is. Purview does not copy, it does not move, and it does not store your actual underlying data.
Right.
The physical records, the rows containing customer credit card numbers, the cells in your financial spreadsheets, the actual text inside your legal contracts, that data stays perfectly, safely put exactly where it currently lives.
So if it's in a highly secure Azure SQL database behind a massive firewall, it just stays there.
It stays there. If it's sitting in an Amazon AWS server, it stays there. If it's on a physical hard drive in your basement, it stays there. Purview never reaches in and extracts the records.
Okay, but if it doesn't have the data, how on earth is it governing the data? What is it actually doing when it connects to a database?
It acts as a scanner. It connects, it looks at the database, and it reads the metadata. It extracts data about the data.
Okay, when I was reading the source material on this earlier, a very specific real-world image popped into my head that really helped me grasp this immediately.
Oh, I love your analogies. Let's hear it.
Okay, so think of the enterprise data estate like a massive historic library, like a multi-story building containing millions of books.
Okay, I'm picturing it.
Those books are your actual data. The pages contain the patient records, the financial formulas, the intellectual property.
Okay, the books are the data.
Now, when you walk into a massive library, you don't just start wandering the aisles pulling books off shelves at random to find what you need.
No, that would take years.
Right, you walk up to the front desk and you use the digital card catalog.
Right, the catalog index.
Exactly. That catalog tells you the title of every single book. It tells you the author, the genre, the publication date. It tells you the exact floor, the exact aisle, and the exact shelf where the book is located.
Yeah.
That catalog is Purview. And the information inside that catalog, the titles, the authors, the locations, that is the metadata.
That is a phenomenal way to visualize it. It really is. Let's push that analogy even further.
Let's do it.
The catalog describes the books perfectly, right? It gives you total visibility into what the library actually owns.
Exactly.
But the catalog itself does not contain the actual pages of the books.
No, it just points to them.
Right. So if a thief breaks in and steals the entire card catalog computer, they have stolen the locations of the rare books, but they haven't actually stolen the rare books themselves.
Oh, that's such a good point. The books are still locked in the vault downstairs.
Exactly. And just as importantly, the act of creating that catalog didn't require the librarian to load all the millions of books into a giant truck and move them to a different building.
Right. The books stayed on their shelves while the librarian just walked the aisles and jotted down the metadata.
Metadata, not data.
Okay, I feel like I have a really solid grasp on the philosophy now. But let's look at the engine that actually builds this catalog. The sources keep referring to something called the data map.
Yes, the data map is the beating heart of Purview. It is the cloud-native metadata storage and processing engine.
Go ahead.
So when the automated scanners go out into your environment, the data map is where all that harvested metadata is digested, stored, and indexed.
And the documentation is very specific that it doesn't just grab a simple list of file names, right? The data map categorizes this metadata into 4 distinct layers. It's much richer than just a simple library author and title card.
It is deeply multidimensional, and those 4 layers are critical for actually understanding the enterprise. Let's break them down.
Sure.
The first layer the data map captures is technical metadata.
Technical metadata. So what is the scanner actually pulling here?
This is the raw structural blueprint of your data. It's the information that a software engineer or a database administrator really cares about. When Purview scans an Azure SQL database, the technical metadata it extracts is the schema.
The schema. So we're talking the names of the tables, the names of the specific columns.
Exactly. And the data types. It records, okay, in table customers, there is a column named birth date, and the data type is formatted as a date string.
Right.
There is another column named account balance, and the data type is a floating point number. It maps the physical architecture of the asset.
So bringing this back to our library catalog, this is like the physical dimension of the book. It has 400 pages. It is a hardcover, and it was printed in 2022. It's just pure structural fact.
Perfect. That's layer 1. But as we discussed earlier with our marketing director example, structural facts are often completely useless to a business user.
Yeah, totally.
If a financial analyst sees a column named REVQ3ADJ99, the technical metadata just tells them it's a column of numbers. It doesn't tell them what those numbers actually mean.
Which brings us to layer 2.
Layer 2 is business metadata. This is where we add the necessary human context. Now, this layer isn't usually discovered automatically by a scanner. It is curated by the human data stewards we talked about earlier in the federated model.
So this is the translation layer.
Exactly. The data steward logs in and attaches a plain English description to that obscure column name. They add business glossary terms, officially defining what adjusted Q3 revenue actually means according to company policy.
And crucially, the sources mention that this is where ownership is defined.
Yes. The business metadata records exactly who the data owner is and who the data expert is.
So if I'm building a report and the data looks completely wrong, I don't just stare at a broken database. The business metadata gives me the name and email address of the exact person whose desk I need to march over to.
It provides complete accountability.
Okay, so we have technical for the structure and business for the human context. Layer 3 is semantic metadata.
Semantic, meaning how things relate to each other.
Precisely. Semantic metadata provides relational and classification context. It helps the system understand the meaning and the sensitivity of the data.
But wait, how does it do that without humans tagging every single row? That sounds impossible.
Through automated classification rules and pattern matching.
Oh, okay.
While Purview is scanning the data to get the technical schema, it's also running the actual data through regular expressions and machine learning classifiers. It doesn't keep the data, but it observes it in transit.
Ah, so it acts like a speed camera on a highway. It just watches the data fly by.
Yes.
If it sees a pattern that looks like 3 digits, a dash, 2 digits, a dash, 4 digits, the classifier says, hold on, that looks exactly like a U.S. Social Security number.
Exactly. And when it sees that pattern consistently in a column, it attaches a semantic metadata tag to that column, classifying it as highly confidential PII.
That is so smart.
And it also uses semantic metadata to group things logically. If you have 50 different databases that all support the human resources software, the semantic layer maps them all together into an HR data collection. It builds relationships.
Okay, so we have technical, business semantic. What is the fourth and final layer? The fourth layer is operational metadata. This captures temporal meaning, time-based, and status details. It is entirely focused on data movement.
Because in a big enterprise, data doesn't just sit still.
Never. It is constantly being extracted from raw sources, cleaned, transformed, and loaded into data warehouses for reporting.
Right.
This is usually done by automated workflows called data pipelines, like Azure Data Factory, for example. Operational metadata captures the exhaust fumes of those pipelines.
The exhaust fumes. What does that look like in practice?
It records when a specific pipeline executed. It records whether the execution was a success or if it threw an error and failed. It records how many rows of data were physically moved during that run.
Okay, let me synthesize this because I want to make sure I understand why separating these 4 layers matters so much to an IT professional.
Go for it.
Let's say I'm the CEO and it's Monday morning. I open my Power BI dashboard on my iPad and the chart showing our quarterly revenue has just plummeted to 0. Total panic.
A very bad Monday morning.
A terrible Monday. Under the old siloed model, IT would scramble. They'd check the database, they'd check the network, they'd check the BI tool. It could take days to find the break.
Easily.
But with a data map capturing all 4 layers of metadata, how does this actually change the troubleshooting?
It changes everything because capturing those 4 layers enables Purview to build what is called lineage.
Lineage, like tracing a family tree.
Exactly like a family tree, but for data. Lineage is the visual map of truth. It shows exactly how a piece of information flows through your entire organization.
Oh, wow.
With Lineage, you don't just stare at a broken chart, you click on that chart in Purview, and it visually traces that exact metric backward.
So using the operational metadata, the lineage map shows me that the Azure Data Factory pipeline that was supposed to feed that chart failed at 2:00 a.m. on Sunday.
Right, you instantly know why it's broken.
And using the technical metadata, it shows me the exact upstream SQL database that pipeline was trying to pull from. And then using the business metadata, it gives me the name of the data engineer responsible for that specific SQL database, so I can call them immediately.
You got it perfectly. Lineage is the holy grail of data governance. And you can only build that map if you understand the structure, which is technical, the movement, which is operational, and the ownership of the business.
This is amazing.
Lineage builds ultimate trust because anyone can trace a metric back to its origin and verify its entire journey.
Okay, the library catalog analogy holds up beautifully. We are scanning the metadata, classifying the books, mapping how the books move between branches, all without ever taking the books out of the vault.
It's an elegant system. It really is.
It is elegant, so long as we are sitting comfortably inside the Microsoft Azure ecosystem.
Here we go.
But let's get real here. You said the modern enterprise is a multi-cloud reality. The data isn't just in Azure. It is sitting in Amazon AWS. It is sitting in Google Cloud Platform.
Yes, it is.
And last time I checked, Amazon and Google are not exactly in the business of opening their front doors and letting Microsoft waltz in to read their metadata.
No, they are fierce competitors. Very fierce.
So how on earth does Purview physically reach across the internet into a competing cloud provider, scan billions of files, and pull that metadata back securely without triggering a massive security alarm in AWS?
This is where we get into the brilliant architecture of how Purview bridges the hybrid divide.
Okay.
To understand this, we first have to understand a specific term the sources use to describe the Purview engine itself. They call it cloud native.
Cloud native. We hear that buzzword thrown around constantly. What does it actually mean in the context of this specific metadata engine?
A lot of legacy software claims to be in the cloud today, but really it's just an old, clunky on-premises application that a vendor install onto a virtual server in an Azure data center.
Right, it's just a lift and shift. Old software living in a new house.
Exactly. Being cloud native means Purview was fundamentally designed and coded from day one to operate specifically as a distributed cloud service.
Oh, I see.
Its architecture is built on microservices. This means it has an incredible level of elasticity and flexibility built into its absolute DNA. And crucially, Microsoft explicitly designed it to be completely agnostic to where the data lives.
Doesn't care.
It doesn't care. It is built to govern your entire estate, not just your Microsoft estate.
Okay, I love the philosophy.
Yeah.
But I'm a mechanical guy. I need to know the how.
Let's do it.
Let's take Amazon Web Services, AWS, as our prime example. Half the corporate world stores their data in Amazon S3 buckets. S3 stands for Simple Storage Service. It's just a massive ocean of files. How does Purview get in there?
Purview utilizes an architectural component called a multi-cloud scanning connector.
Okay, a connector. But how does the authentication work? Because if I am an AWS administrator, I am absolutely not creating a master username and password and handing it over to a Microsoft service.
Yeah.
That violates every principle of least privilege security. Passwords can be stolen.
And Microsoft totally agrees with you. You don't use passwords for this.
Oh, you don't?
Not at all. Instead, you establish a highly secure cryptographic trust relationship between the two clouds using AWS's own native security tools, specifically Identity and Access Management, or IAM.
Walk me through the handshake. How does that look?
You, as the AWS admin, go into your Amazon environment. You create a brand new dedicated IAM role specifically for Purview.
Okay.
When you create this role, you configure it with a Microsoft-provided account ID and a unique external ID. This effectively tells AWS, hey, if Microsoft Azure knocks on the door and presents these exact cryptographic credentials, you can trust them.
Okay, so they shake hands cryptographically, no passwords exchanged. I like that. But trust alone isn't enough. What is Purview actually allowed to do once it gets inside AWS?
That's the second half of the equation. You attach extremely specific restricted policies to that IAM role. The foundational policy you must attach is called Amazon S3 read-only access.
Read-only access.
Exactly.
That brings us right back to our golden rule.
Yeah?
Metadata, not data.
Yes.
By enforcing read-only access at the IAM level, AWS physically prevents Purview from altering, moving, or deleting any of the actual files in those S3 buckets.
Absolutely.
Purview is allowed to walk into the library and look at the books, but its hands are tied behind its back. It can't steal them or write in the margin.
Exactly. Now, to be fully transparent, the documentation does note exceptions depending on what features you want.
Like what?
Let's say you want Purview to not just scan the AWS data, but you actually want it to apply security protection tags back onto the S3 objects themselves.
Like stamping confidential onto the actual Amazon file.
Right. If you want that two-way interaction, you have to grant the role slightly elevated permissions, like get objects and put object tagging.
But even then, you aren't granting it the ability to delete the data or move it.
Correct. It is always tightly scoped, and there is one more critical layer of security here that trips a lot of people up.
That's that.
If you are a responsible enterprise, your Amazon S3 buckets are encrypted at rest.
Meaning the files are scrambled, so if someone steals the hard drive from the Amazon data center, it's basically useless.
Right. Usually, this is handled by the AWS Key Management Service, or KMS. Now, if the files are encrypted, the metadata is often obscured as well.
Oh, so Purview can't read it.
Right. So for the scanner to even read the schema, you have to grant that IAM role, the Calamar's decrypt permission.
Hold on. You just said decrypt. If Purview decrypts the file, hasn't it just gained access to the raw data?
Ah, great distinction. It's using the decryption key to temporarily unseal the envelope, just enough to read the structure and run the classifiers, the technical and semantic metadata we talked about.
Okay.
It does this processing entirely in memory within the secure boundary. It extracts the metadata and then immediately discards the data. The data itself is never transmitted back to Azure.
Okay, that makes sense. The engine has to peek inside the book to know what it's about, but it doesn't take notes on the plot, just the chapter titles. So that's AWS. It uses a multi-cloud scanning connector, cryptographic handshakes, and strict IAM roles. What about Google Cloud?
Google is a bit different.
Let's say a company acquired a startup, and that startup runs all its analytics on Google BigQuery. Does Purview use the same IAM role approach?
It uses a fundamentally different architectural approach for Google and for a lot of on-premises databases as well. Scanning BigQuery typically requires deploying something called a share-R.
A share-R. S-H-I-R. Let's unpack that acronym in plain English.
It stands for Self-Hosted Integration Runtime.
Self-hosted. Okay, so unlike the cloud-native stuff that just floats in the ether, this is something I have to actually host and manage myself.
Exactly. Sometimes Purview needs to reach into environments that are not directly publicly accessible over the internet, or environments that require a very specific, localized translation layer to understand the data structures.
Okay.
You can think of a Cherry IR as a piece of compute infrastructure, a secure gateway that you physically install on a virtual machine running within your own network.
So I spin up a Windows server inside my Google Cloud environment, and I install the SHIR software on it.
Yes. And to allow that SHIR to talk to Google BigQuery specifically, you equip it with a BigQuery JDBC driver.
JDBC, Java Database Connectivity. It's essentially an industry-standard translation protocol.
Right. It allows different software to talk to databases.
I love a good analogy here, so let's tie this all together.
I'm ready.
Think of Purview and these integration runtimes like delegates at the United Nations.
Okay, let's run with the UN.
Purview is the central UN delegate. It speaks natively in the Azure language. But it needs to go read a library catalog inside the Amazon AWS Embassy and another catalog inside the Google Cloud Embassy.
Right.
The multi-cloud scanning connector we use for AWS that is like a diplomatic credential, it's a badge that Purview flashes at the AWS guards. The guards check the badge against the IAM role, verify it, and let Purview walk in to read the catalog.
I like that. And the SHIR?
The Google Embassy is a bit more closed off. The central Purview delegate can't just walk in. So, Purview hires a local contractor, the self-hosted integration runtime. That local contractor lives inside the Google Embassy. And that JDBC driver, that is the literal universal translator earpiece.
That is a perfect metaphor.
The SHIR puts in the JDBC earpiece, which allows it to speak the highly specific regional dialect of Google BigQuery.
Yep.
The local HIR reads the BigQuery catalog, translates that metadata back into a universal language, and sends it securely out of the embassy back to the central Purview delegate in Azure.
Spot on. And just like AWS, the local SHIR's access in Google is tightly controlled. It uses a Google service account with strict roles like the BigQuery metadata viewer role.
Metadata viewer. There it is again.
Right. It ensures the SHIR can extract the schemas without ever having permission to access the underlying Google records.
The architecture here is honestly brilliant. You have this unified engine building four-dimensional lineage maps, reaching across the globe into competing clouds using diplomatic badges and local translators, all without moving a single row of actual data.
It solves the fragmentation crisis beautifully.
It really does. But there is a massive elephant in the room.
Oh.
And as an IT professional, I am terrified of this elephant.
What's the elephant?
The compute cost.
Yes.
Let's think about the sheer physics of what we just described.
Right.
We aren't just pinging a server to see if it's awake.
Yeah.
We are sending scanners deep into petabytes of data across Amazon, Google, and Azure simultaneously.
Yeah.
We are parsing millions of complex schemas. We were running real-time machine learning classifiers against billions of rows of data just to extract semantic tags.
There is an immense amount of processing power.
How does the engine actually handle that physical workload without slowing to an absolute crawl?
That's the challenge.
Right. If everyone in the company is searching the catalog at 9:00 a.m. on Monday and the scanners are running in the background, what does the engine room look like to prevent the whole system from buckling?
To answer that, we have to transition from the philosophy of Purview into the strict mechanics. We need to look under the hood of the data map and understand its central economic and performance metric, a concept called capacity units, or CUs.
Capacity units, the CUs. This sounds like the base currency of the Purview realm.
That's exactly what it is. The
Yeah.
sources are very clear on this. Every single aspect of throughput, processing power, and storage in the data map is measured against this baseline metric. You literally cannot understand Purview's performance or its cost without understanding the CU.
Okay, let's define the baseline then. Let's strip away all the enterprise complexity. What exactly does one capacity unit buy me?
A single capacity unit, 1 CU, provides the capacity for exactly two things simultaneously.
Yeah.
First, it provides a guaranteed throughput of 25 operations per second. And second, it provides exactly 10 gigabytes of metadata storage.
I'm going to repeat that so it sinks in for everyone listening. 1 CU equals 25 operations per second, and 10 gigabytes of metadata storage.
Correct. That is the fundamental atomic building block of the entire system.
Okay, let's break those two halves down, starting with the throughput. 25 operations per second. What exactly constitutes an operation in this context?
What do you think it is?
Well, my immediate assumption is that an operation is just the automated scanner reading a database.
That is a very common assumption, but it's only half the picture. If we connect this metric to how users actually interact with the system, an operation is almost everything.
Everything.
The documentation defines an operation as any create, read, write, update, or delete action hitting the metadata stored in the data map.
The classic CRD operations from database management, CRUD,
Yeah.
create, read, update, delete.
Exactly. So let's look at some real-world examples. When the automated scanner running in AWS finds a brand new S3 bucket and adds that definition to the catalog, the engine processes that as a create operation.
Makes sense. It's writing new data.
When our marketing data steward logs into the portal and manually attaches a highly sensitive tag to a column, or establishes a new lineage link between two reports, the system processes that as an update operation.
Okay, so that's a human action.
Right, but here is the one that catches people off guard. When a regular business user logs into the Purview portal, clicks the search bar, and types in the word revenue, the system has to query the massive data map to return those results to their screen.
Right.
Every single one of those search queries is processed as a read operation.
So the human activity on the front end and the machine activity on the back end are all drawing from the exact same well of throughput capacity.
Yes. Human searches, API calls from other software, automated scans, they all count. 25 of those actions of any combination can happen every single second within a single capacity unit.
Okay, that makes total sense for the throughput side of the CU, but I have to pause the explanation right here and play devil's advocate for the listener on the second half of that CU definition.
Go for it.
You said 1 CU provides 25 operations per second and 10 gigabytes of metadata storage.
Yes.
10 gigabytes sounds absurdly tiny. I mean, think about it. The smartphone sitting in my pocket right now has 512 gigabytes of storage.
It does, yeah.
And we are sitting here talking about mapping petabytes of data for a global Fortune 500 enterprise. How can 10 measly gigabytes possibly be enough to hold anything useful? That seems like an immediate massive bottleneck that will force companies to buy hundreds of CUs instantly.
It is a very natural reaction. When we hear gigabytes today, our brains are wired to think about consumer media. But addressing this requires us to gently refer back to the golden rule we established earlier in the deep dive.
Metadata, not data.
Exactly. You have to really internalize what is physically being stored on those 10 gigabytes. We are not storing high-resolution marketing videos.
Right.
We are not storing massive compiled software binaries. We are not storing millions of rows of dense customer transactional data.
Right, we aren't storing the books.
We are storing pure text. We are storing strings of characters, schemas, column names, plain text glossary descriptions, lineage pointers, semantic tags. 10 gigabytes of pure text is an unfathomable amount of information.
Okay, let's do the math on that to visualize it.
Mm-hmm.
1 byte is basically 1 character of text. 10 gigabytes is 10 billion bytes. So that's roughly 10 billion characters of text.
Exactly. The sources note that a single capacity unit of metadata storage actually represents a massively sprawling data estate. It can hold the metadata for millions upon millions of individual data assets.
When you put it like that, 10 billion characters of plain text is basically an entire city library's worth of wooden card catalogs.
It is. For the vast majority of organizations, hitting that 10 gigabyte storage limit takes a very, very long time. It usually represents a highly mature, expansive governance implementation that has been running for years.
Okay, I stand completely corrected. 10 gigabytes of text is massive. But this naturally leads us to the next problem. We have our baseline building block. One CU's 25 ops per second, 10 gigabyte of storage. But what happens when an organization does exceed those limits?
And they will.
Right. What happens when a global enterprise decides to run a massive weekend scan of their new AWS data lake, and simultaneously hundreds of business users log in on Monday morning to search the catalog?
A perfect storm.
Suddenly, the system demands 150 operations per second. Does the system just crash? Do the human searches start timing out and returning errors because the scanners are hogging the capacity?
This brings us to the true magic of cloud-native architecture. The system does not crash, it breathes.
It breathes. I like that analogy. Explain the breathing mechanism.
The documentation highlights that all Purview accounts start at a default provision state of 1 CU. But the engine is built with a highly elastic autoscale mechanism.
Autoscale.
It dynamically and automatically monitors the real-time request load and the storage volume. When it senses pressure, it automatically provisions more capacity units to handle the load.
So it scales up when it's stressed and scales down when it's relaxed.
Exactly, and it scales in very predictable, strict increments. Operations scale in increments of 25 ops per second, and storage scales in increments of 10 gigabytes.
Okay, let me make sure I follow the math here. If my system suddenly demands 26 operations per second, just one operation over the 1 CU limit, what happens?
The autoscale mechanism instantly bumps you up to 2 CUs. This immediately gives you a ceiling of 50 operations per second.
Yeah.
You always have enough headroom to process the requests without dropping anything.
Okay, conceptually, that is fantastic for performance. But practically, this elasticity has a cost, right?
Of course.
How do the economics of this actually work? Because if I'm an IT director managing a tight budget, the word autoscale sounds terrifying.
Oh, yeah.
It sounds like a blank check that will bankrupt my department overnight if a scanner goes rogue.
And cloud vendors are notoriously good at generating surprise bills.
Yep.
But Purview's billing dynamics are very clearly defined to prevent that exact nightmare. The billing is calculated on a strict hourly basis, and the cost for any given hour is based on the peak number of capacity units required at any single point within that specific 60-minute window.
Hourly, based on the peak.
Yeah.
Okay, this is getting a bit abstract. Let's make this real for the listener. Let's run through some specific scenarios to illustrate exactly how this math works.
Let's do it. Scenario 1, the standard baseline. Imagine your system is humming along quietly. It's a Tuesday afternoon. Your human users are doing a few searches. The scanners are doing light incremental checks.
Okay.
Your throughput is only 15 operations per second, and your total catalog metadata storage is sitting at a healthy 5 gigabytes.
Okay, let's run the math. 15 ops per second is well under the 25 ops limit of 1 CU, and 5 gigabytes is well under the 10 gigabit limit of 1 CU. So for that hour, I am billed for exactly 1 CU.
Correct. You are at the absolute baseline. Now, scenario 2. Storage expansion. Let's say you've been running Purview for 3 years. Your throughput is still very quiet today, only 10 operations per second. But over those 3 years, you have cataloged an immense amount of data across AWS, Google, and Azure. Your metadata storage has crept up to 12 gigabytes.
Okay, throughput is low, but the storage crossed the 10 gigabit threshold. It's at 12.
Right.
So because the storage needs the capacity of 2 CUs to exist, I am billed for 2 CUs for that hour, even though my operations are basically idle.
Exactly right. The system provisions the capacity units based on whichever underlying metric throughput or storage requires the higher number. They are inextricably linked.
Got it. Okay, give me a heavy scenario. Give me the stress test.
Scenario 3. Massive enterprise load. Let's say your storage is sitting at 12 gigabytes, but your organization just acquired a new company, and you are running an intensive, comprehensive metadata ingestion scan of their massive data lake to integrate them.
That's a huge job.
It is. During this specific hour, the sheer volume of new schemas being discovered demands 250 operations per second to process all those incoming writes to the data map.
Okay, math time. 250 operations per second divided by our 25 ops increment. That equals exactly 10 capacity units required for throughput.
Right.
My storage only needs 2 CUs, but my throughput demands 10. The higher number wins. So I'm billed for 10 CUs for that specific hour of heavy lifting.
You've nailed the math. And to ground this in reality, the source material actually provides a fantastic narrative example. They introduce us to an Azure admin named Claudia, who works at a fictional manufacturing company called Contoso.
Let's talk about Claudia. What is her administrative challenge?
Claudia is tasked with creating a brand new Purview account for Contoso. Now, she is smart. She doesn't know exactly how big her data estate is going to get in the future.
Nobody ever does.
Right. She wants to keep her initial day one costs as low as possible, but she needs to ensure the system won't crash when she starts connecting major data sources next month.
A very realistic scenario. Nobody wants to buy a massive server they might not use.
Exactly. So Claudia simply provisions the account with the default baseline of 1 CU. She knows that because of the autoscale feature, the data map will elastically grow based on her actual consumption. She doesn't have to guess.
So she just turns it on at the lowest setting.
Right. Now, in week 2, she connects Contoso's massive primary data lake. She initiates an initial, deep, comprehensive scan to populate the empty catalog. Suddenly, billions of files are being parsed. The operations per second spike drastically.
The system senses the pressure.
Yes. The autoscale mechanism kicks in immediately. The system autoscales up, let's say, to 6 CUs to handle that massive burst of write operations quickly and efficiently without dropping a single schema.
So the engine breathes in, expands its chest, and does the heavy lifting.
Exactly. But here is the critical part. Once that initial deep scan finishes 6 hours later, the catalog is fully populated. The system transitions into a light incremental scanning mode.
Right, it doesn't need to work as hard anymore.
It's only looking for tiny daily changes. The human users are just doing occasional searches. The operations per second drop like a stone.
And because it's elastic, the system breathes out. It scales back down to 1 CU automatically. Claudia isn't paying for 6 CUs for the rest of the month just because she had one busy afternoon.
Precisely. It optimizes her costs automatically during the quiet periods.
I really have to highlight how fundamental this shift is for IT professionals. Think about the old days of on-premises hardware.
Oh, the racking and stacking.
If Claudia was buying physical servers for a governance tool, she would have had to predict her absolute maximum peak load 3 years in advance.
Yes, she would have.
She would have bought a massive $500,000 server rack capable of handling that 6 CU peak and then watch that incredibly expensive hardware sit completely idle 90% of the time.
It was the classic over-provisioning problem. You bought for the worst-case scenario and wasted capital the rest of the year.
Yes. But with this consumption-based auto-scale CU model, IT doesn't have to guess. They don't have to fight for massive upfront capital budgets. The system just breathes in and out as needed, and you only pay for the exact capacity you consume measured by the hour.
It completely lowers the barrier to entry.
It really does. You can start small and let the tool grow with your maturity.
It shifts governance from a terrifying capital expenditure to a highly efficient, manageable operational expense.
I do have one final mechanical question on this autoscale mechanism.
Yeah.
I said the system breathes up and down. What is the upper limit of this breathing? Can a system accidentally autoscale to 1 million capacity units because of a glitch and generate a multi-million-dollar bill over the weekend?
That is the nightmare scenario for any cloud admin. But no, Microsoft has strict technical safeguards in place. The sources define what is called an elasticity window.
An elasticity window, meaning a cap on how high it can jump.
Exactly. By default, the autoscale mechanism operates within a tightly predefined range. For the vast majority of standard Purview deployments, the default cap for operations throughput is 10 capacity units.
So it can breathe anywhere from 1 up to 10 CUs autonomously, but it hits a hard ceiling at 10.
Yes. And honestly, scaling between 1 and 10 CUs, which gives you up to 250 operations every single second, is more than enough throughput to handle the daily peaks and valleys of 95% of standard organizations.
But what about the 5%? What if you are a massive global enterprise? What if you are a multinational bank or a global healthcare conglomerate that genuinely needs more than 250 operations a second on a regular basis just to keep the lights on?
If a massive organization consistently exceeds the bounds of that standard elasticity window and needs to burst higher, they absolutely can. The architecture supports it. But it requires manual human intervention.
Meaning they can't just click a button in the portal.
Correct. They have to submit a formal quarter request, a support ticket directly with Microsoft Azure support to coordinate the expansion of that window.
Why require a support ticket? Why not just let them drag a slider up to 100 CUs?
2 reasons. First, it acts as an absolute fail-safe to protect the customer from runaway costs caused by a misconfigured scanner endlessly looping. A human has to authorize the budget increase.
That makes a lot of sense.
And second, it allows Microsoft to protect their own back-end infrastructure. If a customer needs to suddenly scale to 100 capacity units, which is an astronomical 2,500 operations per second of metadata processing, Microsoft needs to ensure that the physical hardware racks running Purview in that specific Azure region are provisioned correctly and robustly to handle that dedicated load without impacting other tenants.
So it's a structural safeguard for everyone. Amazing. Okay, we have covered an incredible amount of ground today. We've gone from philosophy all the way down to the deep mechanics. Let's synthesize the journey for the listener without just reading a bulleted list.
It has been a deep, complex journey for sure.
We started by looking at the reality of the fragmentation crisis, the painful legacy world of siloed oversight, where security, compliance, and cataloging lived in different universes. And we saw how Microsoft Purview solved that by unifying everything into one integrated intelligence model.
And we explored the elegance of the federated approach, realizing that central IT shouldn't be the bottleneck, and that empowering local domain experts like our marketing director to govern their own data is the key to agility.
Yes. And then we hit the cornerstone of the entire platform, metadata, not data, the library catalog analogy.
My favorite part.
We learned that Purview maps the technical schema, translates it with business glossary terms, classifies it semantically, and tracks its operational movement, building a perfect lineage map of truth, all without ever moving the actual books from the vault.
We discussed how that cloud-native engine bridges the intense hybrid divide. It uses multi-cloud scanning connectors and secure IAM handshakes to respectfully read AWS data, and it deploys local self-hosted integration runtimes with JDBC translators to securely navigate Google Cloud.
And finally, we explored the true engine room. We learned that this massive global mapping effort scales seamlessly using capacity units, where just 1 CU provides 25 operations per second and a massive 10 gigabytes of plain text storage.
And the breathing.
Right, we saw how the autoscale mechanism allows the system to breathe elastically, giving IT admins like Claudia the power to handle huge data bursts while automatically optimizing costs hour by hour.
It is a remarkable, elegant piece of enterprise engineering. But before we wrap up, I think it's critical to bring this all back to the ultimate why.
Right.
Why should you, the IT professional listening right now, care about deploying a complex metadata governance engine today?
Why does this matter right now?
Because we have squarely entered the era of artificial intelligence. Every single enterprise on the planet is desperately trying to leverage AI, build large language models, and deploy predictive analytics to gain a competitive advantage.
Oh, for sure.
But those AI systems, they are incredibly fragile in one specific way. They're only as good as the data they ingest.
Garbage in, garbage out, the oldest rule in computer science.
Precisely. If you feed a brilliant AI model fragmented, unclassified, undocumented garbage data, it will confidently generate garbage insights. And worse, if you feed it unsecured PII because you didn't know where it lived, you have a massive compliance breach. Purview isn't just about passing a regulatory audit anymore.
It's about enabling the future.
It is. Purview provides the high-quality, trusted, secure metadata foundation required to safely deploy AI in your enterprise. When your AI systems ingest data that is trusted, where the lineage is unbroken and the quality is verified by the data map, you get accurate insights that drive real business decisions. The metadata map we've been talking about today is the bedrock foundation for the enterprise AI revolution.
That is incredibly powerful, governing the data to feed the AI.
It is. And honestly, this raises one final, slightly provocative thought to leave you with. A thought based on the strategic roadmap sources we reviewed looking ahead to 2025 and 2026.
Let's hear it.
Throughout this entire deep dive, every scenario we discussed involved governing data for human consumers. We talked about human data stewards tagging columns.
Yeah.
We talked about human business analysts searching the catalog for revenue numbers. We talked about human executives trusting lineage maps on their iPads.
Right. Humans interacting with the library catalog.
But the 2026 roadmap highlights a massive impending paradigm shift. What happens to governance when we transition to a digital workforce? Microsoft is actively developing Purview right now to govern autonomous AI agents.
Autonomous agents, meaning AI that doesn't just answer questions, but takes actions on its own.
Exactly. As these AI agents become deeply embedded in your enterprise workflows, autonomously fetching data sets, writing financial reports, making split-second operational decisions, they present entirely unique, unprecedented security risks.
Oh, yeah. Because an AI agent can read data 1,000,000 times faster than a human. If a human analyst gets access to the wrong folder, they might read 10 sensitive files before they are caught. If an AI agent gets access to the wrong folder, it could analyze and leak 1,000,000 sensitive records in 3 seconds. The blast radius is catastrophic.
You see the danger perfectly. And that is why Purview is evolving. It won't just map static data anymore. It is being built to monitor the real-time behaviors of these AI agents.
Wow.
It will use dedicated risk indicators to identify anomalous behaviors, automatically shutting down access to prevent malicious intent or inadvertent data leakage by the AI itself.
So it becomes a behavioral monitor for the machines.
Yes.
Yeah.
The underlying metadata engine you build, configure, and curate today. The beta map, the capacity units, the semantic classifications we spent this hour discussing, that exact same map will be the foundational guide rails for the AI agents of tomorrow.
So the question for everyone listening to mull over is this. We know how to build a library catalog for a human to read. We understand the federated workflows and the IAM roles. But are your organization's library catalogs robust enough, clean enough, and secure enough for an autonomous AI to read them at light speed?
That is the billion-dollar question for the next decade of enterprise IT.
Well, we have certainly unpacked the engine room today to help you get there. Thank you so much for joining us on this incredibly deep dive into the mechanics and philosophy of Microsoft Purview. We hope you leave energized, deeply informed, and ready to tackle that fragmented data estate. Until next time.